Thank you everyone for joining us for this third session on computational BIM webinar with Graphisoft. Today I'll have the pleasure to have here presenting with me Jorge Beneitez from Enzyme, who is our guest speaker. And let me introduce the rest of the team from Graphisoft Singapore. So I have Chidambaram with us, he's our director for the customer success team. Then me, Marcelo, I think most of you already know me, especially from presenting the previous sessions together with this team. Then we have Carlo Riveral, is also from the customer success team, is a BIM specialist. Then we have Ralph Martin. He is our developer here that helps the customer success team. And recently joined Welcome All Vimal to our team. Is also a BIM specialist, and we're very glad to have him on board. So for today's session, this is coming in a series of 4 events. Today's focus is on digital construction. So we already had an event previously focusing on the IDD cycle on the first stage, who was the digital design. And then we held on the 4th of December late last year, the event focusing on digital fabrication. Today we'll have the digital construction. So it's the 3rd stage of the IDD stages, and soon to be confirmed, we shall have the digital asset and delivery management session, which is more for the operation and maintenance of a building. So for those who missed the previous sessions, I will leave here for a while on the screen in case you want to take a screenshot. The QR code and for the YouTube link of the first session. This was the one focusing on digital design. And this one, the session was so long that we had to break it into 2 links. Then we have the previous session on digital fabrication. This is the link if you want to scan and join this or go through this session. Feel free to do so. And now go through today's agenda. I would like to explain to you what we're going through. And basically, after my presentation, my introduction, we'll have a case study from Jorge Beneitez on computational BIM for construction. He'll bring very interesting insights on how we can design having in mind the construction stage, having some concerns that will definitely impact the construction and life cycle of the building. After that, we'll have the BIMx API introduction by our colleague Ralph Martin. He is the best person in our team to showcase to you how we can take advantage of the BIMx API. After that, we'll have a short break, and followed by site progress monitoring with BIMx Archicad and both NFC and RFID tags using BIMx API and HTML. So in this stage, Carlo and Vimal will each one present on how we can take advantage of this technology on the construction stage. In the end, we'll have a Q&A and discussion. So please keep sending your questions. We have a chat panel here, so you just feel free to add your questions, and throughout the session, either my colleagues and I can reply to you, or in writing, or we can leave it towards the end for the Q&A and go through this. So let me give you just a quick overview about Graphisoft. I think most of you already know, but in case you haven't seen it before, basically we were founded in Hungary in '82, and our first product, Archicad, was born in 1984. We've been a member of the Nemetschek group since 2007. So this means that we We belong to the biggest European software company or software house since this period of time, and we have grown a lot being part of this big corporation. So worldwide, we are present in over 100 countries. We have over 80 distributors, and we have 11 subsidiaries, being GRAPHISOFT Singapore and Malaysia, one of them. So our users here are very fortunate to have us directly and liaise directly with us. And we can host these events directly with the industry. A few numbers about Nemetschek. So at a glance, we have 16 brands. I think this is probably the most important part here, under the same philosophy that we should collaborate in the AEC industry, using the best of breed tools to achieve the result that we want to achieve, but in a collaborative environment and focusing on open BIM. So here in Singapore, we liaise directly with Solibri, besides all the Graphisoft products. So the vision from Graphisoft since the beginning was always to implement BIM under the virtual building concept. And this is, even if you find on Wikipedia, one of the earliest messages in this direction that showed up in the industry. So we want to bring BIM into the common practice for design and realization of buildings. So pretty much build virtually before building in real life. So what are the products that we have under our portfolio? So we have Archicad, which is the BIM authoring tool. BIM Cloud with some variations like BIM Cloud Basic, and BIM Cloud as a service. This is our collaborative platform that brings all the users together to design and realize the building. And then we have our BIM Data Access tool. So today we'll have a lot of focus on BIMx, which is the tool that allows us to bring the model, the geometry, the drawings, and the data into site so that we can take advantage of the whole set of information being generated in our BIM authoring tool and under our platform for collaboration. So now I would like to introduce and invite on stage Jorge Beneitez from Enzyme to introduce to you or amaze you with the computational BIM to use to achieve waste reduction through design. So Jorge, please, the stage is yours.
Thank you. 1 second. So first of all, I want to thank Graphisoft and BCA for host this incredible and innovation forum that this series of lectures have been. I'm really humbled to be invited one more time here, and I must say that I'm just the appetizer for this session. I'm gonna hopefully give an overview, quite high level, of a few things that we can do from the design perspective to try to optimize some workflows, and especially the topic that we wanted to research was regarding the waste management and the waste production on site. This is one of the biggest problems of our industry nowadays. So, but later on, a lot of super interesting things are coming, so please stay tuned. Okay, so I'm gonna do a small introduction about me and my company. I apologize for the rest of you that have seen this already maybe 10 or 20 times, but
it's always interesting, I think.
Yeah. Okay, thanks. So my name is Jorge Beneitez. I'm a Spanish architect. I live in Hong Kong, and I'm co-founder of Enzyme APD. We have companies, or we have presence and offices in Hong Kong, in Singapore, in Ho Chi Minh City, and in Madrid. Although we are a very small company, so I think that's quite interesting already. We're mainly designers, architects by studies and by profession, but we have sort of grown like more like digital, in this digital world. So, and we have become some sort of digital savvy people. So we try to implement all these like new technologies in our design, and we also help other companies in the implementation of these workflows, as well as trying to help the industry, speaking in forums and trying to tell our story and try to inspire other companies as well. So me and my partner Eugenio, we started the company with a dream, or perhaps naive, of trying to bring together good design with efficiency and innovation. So there are a few companies out there that are doing this already, and we are really inspired by some of them, but not everyone, and the industry mainly is going the other way, or that was our feeling 6 years ago. So there are really good designers out there, but not really focused on the on how we develop the projects and how can we optimize the processes, the design, bringing things like environmental focus or things like this. So sorry, because I have this panel here from the GoToMeeting. I can't really see, but so anyway, at Enzyme we really focused on this on researching and finding new ways and more suitable ways for the architects especially to develop their projects. We try to always enhance the way that those projects are developed, and we obviously focus on having good design, but that's not enough anymore for us. So we're always trying to find the challenges and the bottlenecks and in the industry, and try to work on those specific areas, solving the problem through technology sometimes, or through logic. So this is our office in Hong Kong. We're a small team, as I said. So we have our main office is in Hong Kong, and then we have Jay in Singapore. Jay is here, and Melissa, Alvaro, Eugenio, Lela are in Hong Kong. Jorge and Alvaro and Maine in Madrid, and we have Chu that it's in Ho Chi Minh City. So we're a very diverse and young group of designers, and we've been using the technology to work together, and mainly Archicad. We have been lucky to work with some of the biggest developers and some of the best architectural firms and construction companies in the world, working together, trying to help them also to develop into meet their goals and their KPIs for their projects. We're also very involved with education, and we have being presenting and giving lectures and workshops in different universities. And I currently am teaching in the SIGRAT, in the Global Institute of Technology in Barcelona, BIM Manager Master. So, well, and this was the key of the highest, the peak of our our history as a company, where we were invited to as keynote speakers in the Key Client Conference, and we shared the stage with Jojo Tolentino and some of the best architects in the world. So for us, BIM is a methodology that really does not understand of scales, and it can really help to develop projects at any scale. So from urban design projects to architectural scale, competitions, residential buildings, museums, to interior design, we can really leverage the power of information and the power of automation that Archicad brings into the architect's everyday practice, and this really help us to focus in what is important, which is the ideas, the design, and this is almost actually our motto, bringing BIM into the design process and using BIM for to create better designs, more informed, and have more control over it. So We use Archicad and among other tools, but Archicad is our main tool. We use it for, to enhance the communication and the way that we communicate and develop our design. So from, like details, facade details, to master plan diagrams, to 3D sections, or to, furniture details, or just for, competitions. We try to just bring and keep inside Archicad all, all of these parts or products of the design process. Try to, improve or try to cut down the, the time and the effort that we put into creating all these beautiful, images and diagrams. Trying to give a little bit more to our clients just by, using Archicad properly. We try to model everything. I think we are a few people here in this forum, in this room, that we share this same vision. Try to model everything, have everything in the design, and try to leverage all that amount of work for many things, right? But one of them, it's the communication. So clients really understand these drawings and these diagrams. And for us, it's not really an extra effort. It's, it's fun. Cut the model in certain ways, show what is there, and don't be afraid to, to show mistakes, because, we model everything and everything is thought out. So anyway, we also, we don't only do this for ourselves, but we have been also working with other companies. Takenaka is one of them. We had this 2-year ongoing collaboration with Takenaka, where we worked together in a few projects. It was very successful. Now they're fortunately running on their own. So we had a really good fun, and we try to do this, and try to enhance the industry in that sense, in that way. So for us, as I was saying, Archicad is our backbone, our platform, but we have been including in our workflow more and more tools lately, and one shines more among the others, which is Rhino and Grasshopper. So we have been kind of following, or at least myself, this this shift on the way that how the architects or how the industry is starting to think the projects now, right? And before I think that the job of the architect was to provide maybe like one solution to a problem, whereas now the paradigm is changing, and the architects work in a way that the information maybe sometimes is not so clear. So we need to and the projects move so fast that we need to provide more like a framework of ideas and parameters that are important for the projects. And by defining those parameters and those relationships, then the project can evolve and can change in a flexible way. So Archicad help us to bring together all that information and all that data. But Archicad is not the only tool, as I said. So we work with Archicad and Rhino-Grasshopper as our main tools, but we also work with the best of the best software, the best tool for the job. So we use Solibri for BIM collaboration and quality control. We use Twinmotion and Unreal and BIMx for visualization and communication. Bless you. We use tools that are in the environment of Grasshopper, free tools that help us for optimizing different things, environmental aspects, or optimization, or for example information management. But we also are believers of this concept of the open BIM. So we have been collaborating with other partners and other consultants, other stakeholders in our projects that bring other solutions, and that we are happy to integrate and collaborate with them. So fields of applications of these technologies are, for example, BIM, and well, when we say BIM, for me it means Archicad. So documentation, automation, parametric design, and formal exploration, bringing sustainability and environmental design into our projects, optimization of different aspects of the design, analysis, digital manufacturing, and optimizing for construction and construction optimization and construction planning. So today I want to give you, throw a few ideas about this topic, which is the waste reduction through the design, right? So that would be our perspective. So what would be the problem with construction waste? So I have been researching, and studies show that construction industry produces, I think, this is the largest polluter from among all the industries, and 50% of waste materials in construction sites are deposited in landfills, and 20% of the landfill material comes from construction waste. And in some countries like China, this figure can go up to 40%. So it's really a lot with the amount of pollutants that we are producing in construction. And construction is I think one of the least efficient industries. So all this material waste has a significant impact in the environment, but also it's an extra cost to the project for the clients, for the contractors. So we need to rethink about how to optimize and how to minimize all that waste. So proper waste management can really reduce this cost, and we can reduce as well the cost in the transportation and disposal. We can reduce the amount the waste and conserve landfill space, and it can increase the site safety and work efficiency as well, increasing the image of the companies. There are various responsibilities that can be shared among the different roles in the project. So the client should consider in their brief and their requirements for the designers and contractors these requirements regarding waste management and waste reduction. Of course, designers have to incorporate this minimization of waste in their design concept, in the selection of materials and construction method, etc. And contractors have also a responsibility. They have to implement waste minimization measures on site, and site sorting, recovery for reuse, for recycle, etc. So there are a few guidelines that among different studies I have gathered. So first of all, we can reduce waste by reducing construction mistakes, by ordering the right amount of materials and getting the right size materials for the job. And these three first guidelines are 100% and directly related to our work, our jobs as architects and designers, right? We can reduce construction mistakes by using better tools and better workflows, and by working in an informed design, like a data, leveraging the data and making the right decisions, we can get those three worked out. Obviously, we can store our materials in a better way, recycle and reuse. We can try new building methods. That could be something that we can also work towards from the design perspective, and choose building products with minimal packaging, and work more closely with our suppliers, forcing them to also optimize their decisions. So which design technologies can we apply? So I mean, we can use lean construction and try to work with more lightweight materials and prefabrication, modular components, precasting, CLT, wood materials, balance cut and fill, and site formation. That will also reduce a lot the wastage on our sites, and obviously design for long life, and design towards reusing or recycle our materials in the event of demolition of the project, right? And then when we have to demolish, then working in selective demolition and trying to sort out the material in different ways. We can, as contractors can even like resell this material that it's being demolished if it has been done properly, and even like get certain return from that too. So I just want to show 4 case studies that are really quick. So I hope I will still be on time. First of all, it's a project that we did in Malaysia, where we were required to work in a site that was quite challenging, a lot of vegetation, and quite challenging site. So we wanted to propose a design for this site that will try to conserve or preserve the site as much as we could. The vegetation was very rich and quite important, and we wanted to minimize the destruction of the site. So in that sense, the proposal, what it tried to do, and you will see how this relates to the topic, try to take the podium, so the typical typology of podium and towers. We took the podium and we elevated to the first story or out of from the ground floor, and liberating the site. And in order to do that, what we tried to do as well to protect the site was to find the spaces and find the locations within the site that will make a balanced cut and fill and minimal transformation of the site. So what we did is we created a Grasshopper script that took the terrain, analyzed them, and compared with the sizes of the typical sizes of the towers, finding which one were the most suitable areas and the areas that will require minimal site formation. So that is, at that time, we were not thinking about the reduction of waste, but this is a strategy that can be applied from the design point of view to reduce the amount of site formation, and therefore the amount of soil that will be removed and then has to be managed on site at that point. After that, obviously, we work on the design proposal, working in Grasshopper and bringing the elements to Archicad, and trying to leverage the the information and so on. But and also trying to work with modular elements. So we work with some modular apartments, and the project didn't unfortunately move forward. But we were also thinking about since all of the apartment typologies were modular, we were thinking about some strategies for prefabrication. But in this example, I wanted to show you mainly the site formation strategies. You can see here a final view of the end project. Another strategy that we discussed before, it's prefabrication and modular design. So this is something that we are working currently in a few projects with Thomson Architecture in Canada. So obviously, modular building designs and standardized layouts and bringing all those components from offsite prefabrications can reduce a lot the wastage and the use of molds or wasted material, right? The factories can really optimize the work on these components. One of the technologies that we are heavily researching and starting to implement in most of our projects is CLT, structural framing and prefabricated parts. So as a result of working offsite, all of these components will be brought on site already ready to assemble, and this will be like an IKEA, almost like a big IKEA piece of furniture assembled on site. And that image that is in the center of on the slide is the amount of waste that was produced in like a week of work and on site in one of these fully CLT projects. So it's perhaps like 1 or 2 kilos of just wood dust. So that's really impressive. And obviously these are technologies that can really help to reduce the waste on site in a dramatical way. So obviously all the cutting and routing for these wood pieces will be done in the factories, and even there in the factories, sometimes they can reuse these pieces for to create or to bring them in other larger components, or even like creating furniture. And if not, they will use these pieces for like biomass. Obviously, all these new typologies and all these structures can also bring other benefits that, as a side effect. For example, CLT structures are way lighter and require much less foundations and groundwork, which also reduces the amount of waste on site. So that's a side effect that also can help. And obviously the CLT is one thing, but also modular construction, like just bringing the elements and assemble them on site, like more complex elements, this will even reduce further the amount of waste. So these are a few examples of some of our projects now, and as I said, in Canada. How it translates this directly into Archicad, we're working with GDL components that have been designed specifically for these offsite manufactured elements. So these GDL components can give us the, like the specific sizes and the specific things that will come from the factory, and with only a few of these objects, we can produce almost all the design inside Archicad, also making very efficient the design process. So that was it, and I want to show you two more case studies. One is how to bring Grasshopper and Archicad for designing towards material optimization. So this is a project that I have shown it a few times. So this is a ceiling that we were working in an large interior design project that we have on site now in Vietnam. So the ceiling had this geometry that was composed by Voronoi cells. We decided on this shape not only because it looks good, but because it really matched the theme of the project. That it was related to water. It was an aquarium, so we wanted to have in this odded shape room some sort of like ceiling that will remind you to like a water surface, right? And also the odd shape of the room didn't really help to create like any directional component, like it would be like a buffer ceiling or something like that. It would be quite strange given the the different directions and different shape of the room. So what we did is we created a script in Grasshopper, obviously, to bring to create the concept design, and we were pressed in time, so we did it in a in a quite efficient way for the design. So just throwing a few random points and creating the Voronoi elements. But we realized that when we started to create the documentation for this, we realized that we had a lot of conditions that we didn't really account for, and that they were going to make the construction process really hard. They were really hard to document as well. So we thought if it's difficult to document, it would be really difficult to build. So we had these problems where we had various types of nodes for 4 segments, 3 segments, nodes that were really close to each other, very small panels, very large panels. So we didn't really thought the design for construction at that stage. So what we did is we use the application Wallasey, which is an genetic algorithm that is used for a multivariable optimization. And what we did is we put the so we rethought the strategy. So instead of starting from like a random set of points, we created a hexagonal grid, and from that hexagonal grid we started to provide movement to the nodes and certain variation for for different conditions, that but also trying to optimize for different conditions which were similar amount of similar size and size for the cells. So we wanted to to have them within certain range. Most of them, we wanted to minimize the number of cells that were cut through the outline, the boundary, and then we wanted to have panels that were not larger than certain amount or smaller than certain amount. So all that together made a much more rich and nicer proposal anyway. And we found out that this was also much more efficient for construction. We knew that all the sizes for the panels will match with within standard sizes. They were all different, but they will match in standard sizes, thus minimizing the number of customized elements that we will find. They were all, the smaller segments wouldn't overlap with the nodes. Larger segments will be within the range of this existing material. And we also managed to have a strategy for naming conventions that we created in Grasshopper. And we managed to send all this information and naming and so on into Archicad, automating all the process of documentation. So you can see here, sending the information to Archicad, and we use simple GDL objects that we created just by saving as a simple shape. And these objects will be placeholders for information coming from Grasshopper and creating the documentation as we needed, the schedules, etc., etc. So this was really, really successful and optimized the process of documentation as well as the fabrication and on-site assembly. And the last case study I want to show is in the same project we had this special cladding for columns that we were creating, metal cladding. This was producing and designing in Grasshopper, and we wanted to we sent all the information into Archicad. We created the schedules in Grasshopper, automating the dimensioning, the naming conventions, and so on. We send obviously the 3D into Archicad for to create, like for coordination and to create documentation. And as I said, we had all these elements scheduled in the Archicad, in the Grasshopper side. They were sent to Archicad as a DWG, and they were, whenever the script was changed and the panels were updated, we will also update the link, and thus you can see here in the bottom right how this was directly put into a layout in Archicad, and they were updated. As we updated in Rhino, we will export again the DWG and update in Archicad. It was not super efficient, but it really worked at the time. Something else that we did, and this is more relevant for the topic that we're talking about today, is optimizing for. So what we did is within the script, we also wanted to optimize the packing. This is called like packing or nesting of all these geometries into like cutting. Into the metal sheets for digital fabrication. So what it does is it's a very simple script actually that anyone can use. We define the sheet size. We create some rectangular grids, and then what we have is all the unpacked geometries. So all these schedules that we had in there, and then we use this component that is called Open Nest that will like packed all the geometries within those sheets. There are like certain parameters that we can follow here, and you can see how, for example, by changing those parameters, we can automate and we can reduce the amount of material that we are using, and thus reducing as well the waste of all this material at once. So this is something that really can help. And then the last case study that we want to show is also how can we use Grasshopper not only for creating all these geometries, but also to analyze, for example, our own designs in Archicad. So we created this simple script that is bringing into Grasshopper the components and the elements from Archicad. You can see here how this is a mock-up that we did in Archicad, where the geometry is not really clean, or the construction method is not so clean, and you can see how through these scripts we can find like these odd areas and odd corners that are created through throughout the whole building, and those will create some problems during construction, stage, and also it will probably make not only the construction more difficult, but create, for example, that in construction we need to sort of like cut material and for example the gypsum boards, etc., in order to adjust to this corner. So this is a really small, really short video that shows how through this script. So you see that's the model that it's not really optimized, and then in Grasshopper we can establish an area that is acceptable, and then we can analyze elements within those using that parameter. And then once, for example, the project is fixed and the geometries are are cleaner, we can see using the same script how those problems have disappeared, and the analysis is shows no problems actually. So we see that one surface that has a problem that actually it's only the top side. So these are different strategies that we can follow from the design perspective that can really optimize and help later on the performance in construction, and surely reduce the amount of waste in our projects. So thank you very much. I hope this set the mood for the rest of the presentation. And I'm available for any question or comment. Thank you so much. I give you back the stage, Marcelo.
Thank you, Jorge. It's again, you always amaze us. It's interesting to see, especially the same project is moving across different project stages as they normally do, and seeing how the mindset evolves, from the from the design stage to fabrication, and now into construction. So you try to keep the same design. I'm talking mostly about the aquarium project. You try to keep the same design, but always optimizing it for construction. So it's also in line with a lot of initiatives from the government here that we like to see. DFMA, we like to see so design for manufacturing and assembly, and it's interesting to see how you are bringing that together, using all these technologies and all these tools to work your magic. Great stuff, Jorge. Thanks again. Hopefully we'll have you very active on the Q&A session, because you always bring the practical side to our presentations. Okay, so now moving forward, I would like to prepare the stage for my colleague Ralph to come in. So basically, I would like to just give a rough, quick overview about BIMx, so that when he's doing the presentation, he can showcase exactly what BIMx API can do. But then you have also a background on how this works. So basically, BIMx is a virtual experience on how to have a taste of BIM. And this runs on mobile devices, it runs on the computers, on tablets, on phones, even embedded on a web browser. So you can, we'll invite those who haven't tried it yet to download from the Google Play or App Store the app, which is the most interactive one, because with the tip of the fingers we can play around with it. And we have been winning the awards, so the A awards, so the architectural awards from Architizer for the last few years. Sorry, the logo here is a bit outdated, but it's always industry favorite as a tool. So I would like to showcase also some kind of examples on how we can see this BIMx. So basically, we have in this video a lot of uses for this. So you can use it on ICE meetings, so you can bring it to the client, use it as a presentation tool, use to check the geometry, the drawings, check many different design options. and then even go and get information, get a glimpse if this is what is built or what is on the design. So it's a good comparison tool to bring your project, your concept, your idea to fruition. So basically, this BIMx has certain capabilities, and to extend these capabilities, we allow to customize this tool. And for that, we have our API. And if you're interested in finding out more, we have our website, archicadapi.graphisoft.com. There you can find the API for Archicad, BIMx, and BIM Cloud, and you get in touch with our development side in case you want to further customize this. Or Ralph and the rest of the team today will show you how by tweaking this we can take more advantage, or we can make the tool deliver exactly what we want. So with this, Ralph, I'd like to invite you on stage to present what this BIMx API can do, and even shows some insider tips on how we can take advantage of this.
I'm Ralph. I'm the API developer here in GRAPHISOFT. So I will show you how to a brief introduction of BIMx API. So start. So as an overview, you can see here the different components of an ecosystem. Archicad here, BIMx model transfer service. This is where we store the BIMx models. And then BIMx app, some other third-party apps or third-party web service. Okay, so Archicad can transfer the models, including the layout and the information inside the BIMx website. And then from there, it can be downloaded to your BIMx app together with those data that was transferred. And then from the BIMx app, here is the part where the API comes into action. It can communicate with your third-party web service and your third-party app to customize or to give more functionality and capability to your already very useful BIMx app. Okay, so here is a sample of how it will look like after you have your API installed in your BIMx app. So you will have different panels like this, or items added into your BIMx app. Okay, so let's go into the development overview. So the basic requirement, of course, is to have a BIMx Pro license. Your normal BIMx app license won't be able to install the add-ons or the extensions. So you will need to purchase the Pro. Also, you will need a developer ID. You can get it from the website that Marcelo showed earlier, archicadapi.graphisoft.com. You also need the idea, what you want to develop, what you want to customize or improve, and then of course the development team to do the work for you for the development. The knowledge requirement for those who wants to hire a third-party developer would be the web services and REST API. Okay, so just a brief introduction for the REST API. You can see here we have a customer ordering a coffee from the cashier, and then someone from the back end or the kitchen will brew your coffee, and then it will be then passed over by the cashier back to the customer. So this is what the REST API actually does. From the client, it sends the request. So the API endpoint will fetch the data requirement and then will give the according response. So, okay. For the BIMx API functionalities, we can do the following. We can add third-party authentication support. So if your website or app has authentication, then you can leverage on that to have a more secure and authenticated access to your data. Okay. Also, we support embedded HTML content because some of the contents here can also be produced by an HTML formatted data. Okay, so you can also add element selections or define selection sets. Like what Marcelo shown earlier, you can open a 2D document using, but this time you can use only hyperlinks. Also define camera position in a 3D model and to get the exact coordinates for the model, so you can use as reference. Okay, so going deeper into developing the actual extensions. Basically, those extensions that we have are created using a simple JSON format. Later, I'll show you a brief introduction of that one for those who doesn't know what JSON is. It's a key value pair, and then the file name for that text file should be BIMxx, which stands for BIMx extension. So JSON is a JavaScript object. It's used to store or transport data. It looks something like this. Okay, so it's really human readable and easy to use. To install the extension, you just need to click the file itself, the BIMxx file, or you can access it via a download link, like one we have here. But it must be URL encoded. URL encoded meaning it should have the % characters so that it can be readable by the machine. Okay, to verify the installation, after you click the BIMxx file, okay, click on the 3 dots here or the add more. Click the installed extensions, and then you'll see all your installed extensions here. This is what the sample extension looks like. So this example is just adding an open sandbox app in the context menu. Later, I'll show you where that is. And then if you click that, it will go to this URL here. Of course, the JSON file needs a structure. So there are some required keys or strings to be added. The name of the extension, what it will show into the app itself, and then the developer ID. The developer ID, again, you need to register with Graphisoft or Archicad API to get your developer ID. Okay, an update URL in case you want your extension to be auto updated. Sorry, hyper model names. If you want your extension to work only on those specific hyper models, and then some selected element context menu. This is where your add-on will be added. Some project info, element info, and then model info. All these others, except for the name and then the developer ID, are optional depending on how or up to what extent you want your extension to have. Okay. On the other side, aside from installing data inside your BIMx app, you can also export data outside to be used by your web app or your third-party web service. So you can see in this example, I have highlighted in orange. We have this variable called element GUID and then model name. So these are then translated or substituted with the GUID and then the hypermodel name to be used by the web app that is going to receive this. So here are some element related variables. GUID, which is the element that is currently highlighted in your model. Okay, and then selected element GUIDs if you have more than one element that you selected. Element ID is referring to what type of element you have selected in your model. Zone ID is the ID for the zone. Just take note that zone ID, if the selected element is not a zone, then it will be an empty string. Okay, some model-related variables: hypermodel name, the name of your hypermodel, like mentioned earlier, project ID, project name, and then there's this first measure point. It's the measurement for the tool. Camera position. Later, I'll show you how to use these things, and then the view direction. Okay, so for the extension points, if you're adding your extension to an element context or an info list, this will help you visualize where it will go. If you add it into the element context menu, it will appear like this. So it will show into your added clicked element. So like this example, if you click this open item database, it will open the sandbox app and then submit your element GUID together with the hypermodel name. The element info list, okay, so this one you can access it if you click the info context menu, you will go to this element info list. You can also add items in here. So in this case, we added this demo element GUID and demo remark. Okay, this works in a bidirectional way. If you click on these elements, it will send the data to the third-party app. Okay, and then it will receive the data that will be filled or updated into these items. For the project menu, project info menu, it will be shown here. So you can also add functionalities that is project wide or project scope. You can also add your extension into the model info dialog. So like what was mentioned earlier, it's actually up to the idea, up to your idea what you want to do with those capabilities. Okay, so here's a sample workflow. If I click the info, okay, so we have this extended elements items that I have added here. And then if you click the edit, it will open the web app or the web service from the third party. Maybe it's your internal website or dashboard. So this one is not already outside of the BIMx API scope. Okay, but this just shows that after you save it there, then you can fetch the details with the updated entries. So from the initial value before change, I change it to BIMx API demo by rank. Okay, so I have here a snippet of the demo extension that I have shown. So the demo remark that you have been seeing in those context menus. Okay, so aside from those, I think transferring of data, you can also do automation with those with the BIMx API. So automation works by creating your own hyperlink with the BIMx application as a literal, the URL plus the parameters. Okay, so to visualize, I highlighted them. Okay, so here's an example. First, what are the things that can be done inside? So I created this web app to showcase what the automation does. Okay, so first I will open the hypermodel using this link. So after clicking the link, then it will automatically open your BIMx in your phone or your device, and then open the hypermodel. Also, you can highlight the elements using links. Okay. So these highlighted elements are treated as selected elements. So you can unselect it or deselect it when you want to. Okay, you can also group the elements. Okay, so you can see that there are different color coding schemes depending on how you want to present your model. And also you can highlight the specific element with a certain criteria camera position. And then last but not the least, you can open 2D documents also using hyperlinks. So this way, you can just send an email to your client or to your colleagues with these URLs, and then they will see what you want them to see. Okay, now going deeper, how to or what are the examples of these URLs or hyperlinks? Okay, so like mentioned earlier, I have the orange portion highlighted. This means that these are the parameters. Okay, to open hypermodel, you need to use the show hypermodel contents, and then the only thing you need would be the hypermodel name. To highlight the specific models, you need the show element in 3D context URL. So this will look like BIMx application. Then this part all together, no spacing, and then no new lines. Okay, I just separated them just to give a more easier visualization for you guys. Okay, so hypermodel name, then the GUIDs. Also, the one that you seen earlier about the grouping. Just take note that you can only set up to 8 groups, and then each of them have their own hard-coded colors assigned to them. The color coding cannot be modified. And then you can set the camera position. And then opening the 2D documents. Okay, so here are some sample BIMx API use cases to give you an idea what you can do with it. Okay, so for progress monitoring and commissioning, you can set the completeness. Okay, so these ones are coming from a web service or a web app or an application. So, and then after they update it, then it will reflect on the other side's database as well. So they will keep the checking and then the collaboration seamless. Okay. Also, you can do a maintenance request form. This is just one of the ideas or examples that you can do. Okay, you can add a menu here that will spawn a form, a web form, for you to submit to your vendors or to your contractors. Also, since we have the capability to embed HTML canvas into the BIMx app using the API, you can also have a live camera stream embedded into your BIMx app, thanks to the HTML capabilities. Those are just the other use cases. So here are some more. You can do on-site issue management. You can tag something as an issue and then group them accordingly. You can also monitor construction progress. Later, my colleagues Carlo and Vimal will show you a demo use case for construction progress monitoring. You can also have home automation, maintenance request submission, building management, and even dashboard access. So since we're transferring data outside of the BIMx model, you can then use that data and create your own dashboard for your needs. Okay, live sensor data and many more. So this has been all for the very brief overview of what the BIMx API can do. Here are some links and references. So that's all from me. Thank you for listening. I hope you have some idea now what the BIMx API can do.
Great
Okay.
stuff, Rob.
Yep.
Great stuff, really. I think even for me, I always knew that there's a lot of things that could happen, but you explain in a very simplified manner. I know that it's quite tough for you to come down to these simple terms. I hope everyone managed to see the value of it. Pretty much, there is an array of options or of opportunities that we can take advantage to leverage on the BIMx API capabilities, and to take, to use more extensively the BIM model and the data that we have from this. So I think now we could go for a short break. We had a, I don't know, 20-minute break, but we probably, since we're a bit behind schedule, can we make it about 15-minute break and we start in 15 minutes from now? And after the break, we will have the session with Carlo and Vimal that will show how to monitor the site progress with BIMx, Archicad, NFC and RFID tags using the BIMx API and HTML. Okay, so thank you very much all for staying there. Let's meet up in 15 minutes then. Let's take a short break now. Thank you. Okay, so good afternoon, everyone, again. I think we can start shortly the session then. For now, we will have the pleasure of having Carlo and Vimal presenting on the site progress monitoring using BIMx, Archicad, BIMx API, and HTML, taking advantage of the hardware of NFC and RFID tags. So I think without further ado, I would invite first Carlo to present.
Okay, so hi everyone. My name is Carlo. So my topic is all about monitoring site progress using RFID. But before I start this RFID thing, I want to show you something which is more onto the 3D printing side using Archicad. Okay, so let me show you first the previous computational BIM session we had. So as mentioned by Marcelo, so we did finish the computational BIM for documentation, computational BIM for manufacturing, and then now is computational BIM for digital construction. Okay, we do have another session, but I don't have a date yet, which is more on the computational BIM for facility management. Okay, let me show you what we have done so far in the previous session. So basically, we auto-generate QR code using Python based on the element ID. Okay, and then what we did here is transfer or scan the QR code to your phone, and then after that, it will verify the location inside the BIMx application. So let me fast forward a little bit so that you can see the progress. So as you can see here, so we generate all the QR codes. Then as you notice that the BIMx app will automatically pops out and then give you a notification to open it. Okay? As you can see here, it opens and allocate the element. I think one of our clients is here. They already use this workflow together with another group. Okay, so yep, so let's move on to the topic, which is 3D printing with Archicad. So of course you need Archicad as your modeling software. You need to have 3D printer, of course, and then slicer tool. Slicer tool means this is a software that slices your model, means slice it layer by layer. Okay, let me quickly show you a quick one. Again, this is not my main topic. This is just a side topic. Let me show you how Archicad, how you can use Archicad for 3D printing. Actually, it's very straightforward, but of course, you need to know the basic knowledge about 3D printing like understanding the bridging, refraction, overhangs, and some of the 45-degree rules. Okay, just select the element, and then you can just actually save this one as STL directly. Okay, some 3D printer actually accept STL print directly, but mine, I need to convert it to G code. Okay, so let me fast forward a little bit to show you the process. So once I have the model saved to STL, now I can import the model inside my slicer. Okay, as you can see, the scale that I use here is 1:100. So it's up to you to set which one you prefer. But normally, maximum I think is 100. Really depends on your nozzle resolution. Okay, as you can see, it slices layer by layer. Then after that, you can send this one to your 3D printer. Again, I'm using another slicer here. This is more easier. So just import the STL file and then export to G code. Okay, quickly show you that here. Yep, so this is how it looks like. So this is a 1:100 scale model from Archicad. Okay, so that's it for the 3D printing part. This is just a side topic. So my main topic would be more on to monitoring site progress using RFID with Archicad. Okay, so we're going to use Python and Google Sheets. Google Sheets is using JavaScript, I think. And then we're going to use some Arduino for this exercise. Okay, so again, what is RFID? So RFID is a radio frequency identification. So it is a wireless non-contact use of radio frequency waves to transfer data. So you can actually tag items with RFID stickers. This allows you to automatically and uniquely identify and track the inventory or your elements or assets. It is used for vehicular tracking, manufacturing, mining, asset tracking, and many more. But in construction, actually, this is used already by some of the contractors, but I heard NTU and JTC as well is using this one for a long time. So this is not really a new technology. So the purpose of this presentation is just to show you that Archicad can do RFID tagging and digital construction. Okay, so that's the main focus of this presentation. So as you can see here, this is a typical process for digital construction, or you can say this is like a PDC method. So first, all the item will be manufactured offsite, then it will be delivered on site. Okay, then in these images, they use QR code, but in my presentation, I'll be using RFID. But again, there are, of course, common challenges using the old method in monitoring the site progress. So managing non-graphical data on site, it is one of the overwhelming tasks. So best example is to receiving delivery information or monitoring site progress on site, basically checking delivery progress screens as well. So this is more onto QS work, but most of the company uses BIM in their project, but managing non-graphical data was still a manual process. So this leads to data loss or discrepancy due to miscommunication or human error. So with the help of BIM and RFID, this process can be automated using Archicad BIM model and RFID system. So as I mentioned, this is the focus of my presentation. We can use Archicad for digital construction using RFID. Okay, so what is the plan or strategy for this workflow? So what we're going to do is, first thing, we need to have a Google Sheets. We're going to use cloud-based Google Sheets. Then the next step would be, of course, we need to have a model in Archicad. Then we will create a Python script for that to transfer the data to the Google Sheets. So I need to transfer all the elements inside the Google Sheets. Then after that, we're going to create a DIY RFID. Then I will try to simulate the actual construction process. Okay, so again, this is one whole process. It's two-way, not one-way. So let me show you some demo here. So I will show how the workflow works before I go through with the codes. Okay, so we try our best. Can you see my video, by the way? Hope you can see it. So here we have this Archicad model. Let me show you some properties that we need for automation, like for example, the status and the timestamp. So what we're going to do here is try to transfer first the GUID element type and the marking inside the Google Sheets. So we're going to use Python for this one. Again, later I'll show you how Python works. Okay, so we have these Google Sheets with me. So I will automatically fill up all the information except for the status and the timestamp. The blue one that you see here, this is the RFID number. So you can actually just key in, depends on your RFID tag. You can manually key in this one here. So once I load my Python script, what it does, so it fills up the information in the column A, B, and C, which is the GUID, element marking, and type. Okay, this is the first process we need to do. Then after that, I'm going to simulate the construction process, like from the manufacturer or subcontractor traveling to the site or the main contractor. So just an example on your right side, this is the manufacturer's country. Then once it passed through, then you will see this Google Sheet updated out for delivery. Then after that, once it passed through the next country, which is a main contractor, you will see it's delivered. So this is the workflow. So what we're gonna do is try to simulate the actual construction. So once all the information in the status has been filled up, then I will transfer this data to my Archicad and verify using the 3D view. Okay, so as you can see, it goes through the country and then pass the information to Google Sheets. Then after that, we're gonna pass this information to Archicad. Okay, as you can see, there's a timestamp as well. Okay, so every element that passes through the country, it will be updated in my Google Sheets. So once everything is ready, I can now visually check in my 3D view or in my schedule what's going on site. Okay, without going to site, I can check what is the status now. Okay, I will run the script now to pass the information to Archicad and see how this one will be transferred. As you can see, all the yellow one is the outward delivery, and the green one is delivered on site. Again, this is a very simple process. Later, Vimal will show you a very detailed one using NFC. Okay, so as you can see, I managed to transfer the data to Archicad from Google Sheets. So what if I have another update? For example, I will tap again and see what's gonna happen. I still have 1, 2, 3, 4, 5 deliveries going on. So now it reaches site, turns delivered, right? So it turns green. So all the data now has been updated. Then I want to check the updates digitally. So means I will use my Archicad to view it. Okay, then what I'm gonna do is just click and run the Python code again. Okay, this is just like updating the model I have. So imagine I could check the model virtually without going to site. Okay, as you can see now, everything is updated. I still have one pending out for delivery. This is just to show you that I have this color coding system. Okay, so yep, that's it for the Archicad workflow, trying to mimic the actual construction on site. Okay, so let's go through the process. This is a bit heavy. Okay, so how it works. So first thing, we need to create a Google Sheets. Then what we're gonna do is link the Google Sheet to our RFID module. Okay, so again, this is a DIY process. Then, yep, make sure you create your Google account, create new Google Sheets, and of course, into name it. I'm not going to go through very detailed on the JavaScript because my focus is more on Archicad Python, but I'm going to show you what are the settings you need to do. Okay, so yep, now we are here at the Google Sheets. So inside Google Sheets, actually, they have this Google app script. It's a Java-based language. Once you click this editor, it gives you the access to the API. Okay, the first thing you need to set up is your first time zone, date time format. This is optional, but of course you need to have the timestamp, so you need this one. Okay. Then after that, the most important part is the log spreadsheet ID. So this is basically your kind of GUID for your Excel sheets, something like that. Okay, so you need to copy paste as well later. Okay, so once I have that, I need to create if condition. So again, this portion, as you can see, if entrance is equal for out for delivery, actually this line here is referring to the RFID tag. Later, I will show you the hardware part and the software part. So once I tap the tag, it appears here, something like that. Okay, then after that, it will fill up the form. Okay, so now let's move on to the hardware part. So once we set up our Google Sheets, need to go through with the hardware. As I mentioned, this is a DIY. This is not really an industrial grade RFID. So what are the recipes we need? First is we need to get this RC522 module and to node MCU. You can get more actually, but for this exercise, I'm planning to simulate only the output delivery and the delivered. Later, Bimal will show you how to automate the NFC part. So means it's more detailed. Output delivery, it could have damage on site, installation, and so on. Okay, so but my presentation will be more onto proof of concept. Okay, so you'll be needing this node MCU, and then 2 pieces of LED and a buzzer. Okay, then after that, you need to power up this node MCU. So node MCU is a Wi-Fi base, so you can actually bring it anywhere you like as long as there is a Wi-Fi. Okay, then of course some wires, and the most important part is the RFID tags. Okay, so that's it. So once you have this one set up, you need to go through the Arduino IDE. This is a C++ based IDE. Then there's a lot of libraries inside, but again, I'm not going to go through with the details of this because the focus is more on to Archicad pattern. But I'll show you some basic settings here. Like for example, you need to set up the Wi-Fi password and your Wi-Fi name, depends on your location. Then again, as I mentioned, about the Google Script ID. Okay, you need to copy paste this one. This is the one links to your Google Sheets. Okay. Then, as I mentioned earlier, we have this variable unit name out for delivery. Okay, this is the one. These variables will be sending to Google, and we will create a condition on that. Okay, yes. So this is my Arduino side. So once I set up everything, then I will now use the Google Sheets. But this is how it works. In summary, we have two RFID tags. One is on the manufacturer side, and one is on the main contractor. So once it passes through this country, updates the Google Sheets, like for example the status, and then once it passes through the main contractor, it will update again the status to delivered. Then all the data here we will be transferring it in Archicad. Okay, so now this is the main topic I have. This is more onto Python. So we need to connect Python Archicad to Google Sheets API. So this is the flow now. The plan is to, of course, we need to have a model. And after that, once the model is completed, we need to transfer the data inside Google Sheet using Python. Okay, we will be running two scripts as shown in the video. So we have one is Archicad to Google Sheets, and the other one is Google Sheet to Archicad. You can combine this one, but yeah, for this exercise, we want to show two scripts for you to understand the process. Okay, so the first thing we need to do is, again, transfer the data to Google Sheets. So there is one settings that you need to do in the Google Cloud Console. For more instruction, actually scan this QR code, but I will go through with you the basics. Okay, so the basic things, of course, you need to have a Google account. You need to go to Google Console Cloud Platform. Then after that, you need to create a project. Then enable Google Drive API and the Google Sheet API. And after that, you need to copy paste service account email. Then the most important part is download the JSON file and then save it to your local drive. Okay. Then yes, in the Archicad side, we need to have these Archicad libraries. But again, if you're using Archicad 24, everything is there already. Okay, but again, we need to install the Google Sheets libraries, which is GSpread. Okay, you need to install this one inside your Python. Okay, so this is the plan for those not familiar with Archicad. So the plan is get information from this BIM, transfer it to the Google Sheets. So in here in Archicad, we have this element information, right? But we're not going to transfer all the information. So we try to simplify this process actually. So we will only get the GUID marking element type, of course the status and the type. But of course, this value is empty for now because we're gonna populate this one later. So once I run the script, it will show you the GUID only, marking and type. Okay, so I have a snippets here. Then the first thing you need to do is import the GSpread. You can't import the GSpread without installing the library. So you need to pip install the GSpread first before you could import here. Okay, then after that, we need to set the Google Sheet connection. Remember, as I mentioned earlier, we did save a JSON file in my local drive, right? So we need to add that local directory and indicate the Google Sheet name under this sheet variables, okay, which is the Archicad RFID card. Okay, then after that, we need to establish the connection. So every script that you create, you need this one. Okay, this is the Archicad Python libraries that you need to initiate. Okay, so as you can see here, this is optional, but it is best to have this assertcon. This is more to debugging, so it will send you error if you lose the connection. Okay, so then you need to create the variables for the command types and utility. This is more to the Archicad modules. Then the plan is we will be using filter and classification in Archicad. So means I'll be using classification to filter out. Okay, so the plan is create this script to search for Archicad classification BIM. Okay, so means I'll be searching for BIM only for this exercise, but again, you can actually select all or get all element types. Then next step would be get the property value in Archicad. So what it does, it gets all the property of that selected elements. Okay, so as you can see down here, construction progress, right? This is the group, the name of the property, and we have status, element marking, timestamp. So this is all the properties that we need. And the next step would be writing the data into Google Sheets. Then we need to look through the directory. So from the row and write each row into the Google Sheets. So what happened here is that's all the dictionary and place it row by row in Google Sheets. Something like this, okay, down here. Again, it creates a loop for the dictionary and then place it row by row. Yep, so that is the first script we have. Then the next one would be transferring the data from Google Sheets to Archicad. Okay, so now the plan is once you tap the RFID tag, right? So this one will automatically populated and fill up. Then what we're gonna do is transfer the data. So again, the initial setup is the same. So we have this setup import in Google Sheet. Okay, so GS spread, you need to import, and then again, of course, Archicad connection. And after that, yes, start to have connection. Then after that, we need to create a variables and use it to get the latest data in the Google Sheets. Then once we get data in the Google Sheets, we need to create a property and create an internal storage to place all the data there. Okay, then after that, we need to get the values from the Google Sheet and create a for loop. Then store the new value, append and return the value in Archicad. So this is the one sending the new values in Archicad. As you can see down here, this property status and timestamp will be automatically updated once you run the script. So this is how it looks like. So for those who are not familiar with Archicad, so we use graphic override rules here. So let me explain what is graphic override. So inside Archicad, we can control the graphic display. So what we did here is assign green color for delivered and yellow for the output delivery. We can add more rules like, change the color for installed element on site, or you can change the color of damaged element on site. Again, Vimal will show you this method workflow, sorry. So we'll show you more detailed approach, but this time I think he's using NFC. Okay, so it's a different approach on mine. Okay, so I think that's it. Thank you very much.
Great stuff, Carlo. So now, Vimal, are you ready to jump on stage?
Sure.
Yeah, great.
Thanks, Marcelo, and thanks, Carlo, for your presentation. Hello, everyone. This is Vimal. I'm a recent addition to GRAPHISOFT family. So, having seen the RFID system for tracking, we are now going to see NFC-based tracking system, which is a cost-effective alternative for RFID. As the name goes by, NFC is a near-field communication tracking, which is a short-range wireless communication technology that enables compatible devices to transfer digital data that include URL, text, hexadecimal numbers, contacts, addresses, location data, etc. And NFCs are similar to RFID, just that NFC has much shorter range compared to RFID. So for this tracking system, the hardware requirements are just a mobile phone, which is NFC compatible, and of course the NFC tags. Okay, so the philosophy behind this system is similar to what Carlo was showing. So we need to tag each and every component with NFC for tracking the component along the construction project lifecycle. So yeah, so which is also performing other tasks like production tracking, delivery tracking, stockyard management, approval tracking, and also it with the other IoT modules, it also helps to achieve just-in-time delivery. So having all that, since the system is cloud-based, we can see the statuses of BIMx, components, the construction in BIMx real time using any device. So I'll go into the system architecture where with the Archicad model ready for construction, we can set up our own database. The database here in this demo or Google Sheets, of course, we can go for any cloud-based database services and go ahead with the project. So yeah, we are using Python script to populate the database from Archicad model, which was shown by Carlo in the previous presentation. And in the second one is to use BIMx. We are using advantage of BIMx user interface to extract the information from the component and write it into the NFC tags. So the information that we are going to write into an NFC tag is the GUID. So with GUID into the tags, the component can be attached to the tags can be attached to the components, which will pass through different construction processes. So once when it comes to different stages for scanning, we can use mobile phones for scanning. So basically, we are just using mobile phones and are using web browsers like web applications to read and write NFC tags. Of course, there are some certain limitations with this, which I'll address in the further slides. But basically, we are using mobile phones with web browsers. Yeah. So after reading the scanning the data, we are going to populate the information into the Google Sheets. So when the Google Sheets are updated, we have to now update the Archicad model with the current progress. So in order to update the Archicad model with real time, we are using Grasshopper, Rhino-Grasshopper in the backend to do this. And after the Archicad model is fully updated, we can visualize them, as I said earlier, we can visualize them in BIMx model using the shared URL. So we will first see a short demo of this NFC tracking system. So here in this demo, we'll be seeing tagging individual components and also tagging multiple components in truck. The reason for tagging multiple components in truck is that in RFID system, when the truck passes through the gantry, the fixer readers will read all the components data from the RFID tags and automatically update the status. But since NFC is a low range technology, users have to go around the truck and scan each and every component. In order to avoid that, we can we can tag multiple component information into one tag and fix it along with the truck, so that when the truck leaves and enters the production plant and enters the construction site, we can scan and then update the status accordingly. So of course, we are going to scan and update the status at different stages in this demo, and then we are going to visualize the status in BIM model also. Yeah, so first is tagging individual component at precast plant. So let me first explain the windows in this screen. The leftmost is the BIMx screen from a mobile device shared using any desk, and this one, the middle one, is the Google Sheets with all the information color coded for different statuses, for different stages. Yeah, and the top right is the Archicad model, which is updated previously, and the below one is the video which is showing the user scanning and updating the necessary information. Yeah. So now the user is using BIMx model to scan the to write the tag. So we can zoom into the particular component and then write. Just a minute, I'll show you. Yeah, so this write NFC tag is an option that was created by BIMx API. So using this API, we are going to extract the necessary information, which is GUID in this case, and then pass it on to a web browser, which will do the writing into the tag. So once when the user clicks write tag, it goes to the web browser, which can be written into the tag. So after that, we are going to see how to tag multiple components. Now we have to select multiple components in BIMx model and then go to model settings and go to the corresponding BIMx API and then write multiple tags and then fix it to the truck. So once when the truck leaves the production plant, we can scan and then update the status that the truck is out for delivery, which gets populated in the Google Sheets. Sorry. Yeah, which gets populated in the Google Sheets, and also it gets updated in the Archicad model real time using Rhino and Grasshopper. So when the truck leaves for delivery, and then when it comes to construction plant, the user in the construction site can scan the truck and update the status for components. So here we have 3 components. So the user is updating the status for each, which get populated in the Google Sheets real time, and then it gets reflected in the Archicad model in real time also. So having seen this, we will see how to scan the individual components for installation. So the user or the signalman can read the tag and then update the status as installed, which gets reflected in the Google Sheets and also in the Archicad real time. So after having the Archicad model, which is up to date, we can now see the BIMx, where we are using a web services to generate the URL that can show the information on BIMx model. So the information in BIMx model are color coded so that anyone can view this information with the shared URL to know the status of the project. So coming back to this system architecture, I'll go through each and every module to help how to set up these modules. So since the first module for populating the database was already explained by Carlo, I will skip that part. Thanks, Carlo, for that. And I'll just show the Google Sheets and show the information flow with respect to this NFC system. So for this, we need the GUID marking and the type, which has to be from the Archicad model using Python script. And of course, the state, as we saw in the demo video, the statuses and timestamps are going to be populated using the web services from the mobile app. So having done with the Google Sheets or the database, next part is to see the BIMx model, from where the user is choosing the component and then extracting the information using the API and writing it into the NFC tags. So for that, again, we are using the BIMx API, which is basically, which is basically extracting the GUID of the element and then passing it on to the web application using query string. And after that, we are going to write the tag with GUID. For this, as I told earlier, we are going to use web services written using HTML with JavaScripts inside. So as I told earlier, there were some limitations for web services for scanning and writing tags, NFC tags using browser. The problem is this technology is very new, that there are some applications that could be developed on mobile phones to read and write tags, but using the browser, currently there is only one browser, which is the Google Chrome beta version in Android is able to do that. But this update has come very recently on February 2021. So which means we are expecting for this technology to be coming in other browsers and other devices also. But it doesn't mean that we cannot do anything with the other devices. We can still use other devices, but still cannot do it with the web page. We have to develop an application for that and then do reading and writing. Having said that, we are writing the tags with GUID information, and then for scanning the tags when it comes to the coming across the stages in construction processes, again we are using web services with the JavaScript inside, and again for scanning the same limitations apply. We can only use Google Chrome beta version in Android currently. So this code snippets are very simple, that we are just writing the GUID information as text data and then scanning it back to write it into the Google Sheets. So having done with the scanning, we'll see how to update the status into Google Sheets. So we are going to use Google Sheets API for this to write this. So in order to use Google Sheets API, we must have a Google Cloud Console project, which will help us to generate the API key and the web client. So here is the link which you can follow and check how to create a Google Cloud Console project and then develop this API key and the web client authentication ID so that you can use it in your web browser to write it into Google Sheets. So basically, as I told earlier, we are getting this API key and the client ID from the Google Console project and then getting the authentication to read the Google Sheets, which means that our Google Sheets are secured. If there's no authentication, the user will not be allowed to read and write the information from the Google Sheets. And in the left side, we are using JavaScript to write the information into the Google Sheets using the Google Sheets API. So we are basically iterating through the data in the Google Sheets and identifying the corresponding information that was recently scanned, and then we are updating the status. And after that, with all the Google Sheets updated, we are using Rhino-Grasshopper to update Archicad model, which is real-time and automatic. So for this, we are using Grasshopper, right? So Grasshopper is the node-based platform which performs computations for BIM data. There are default nodes available on Grasshopper, which I'm not going to go into much detail, but there is a node which is a Python script where the users are allowed to write their own Python scripts and to create their own program using the Grasshopper Python script. Yeah, so basically we are having 4 main Python scripts here in this project. The first one is similar to what we saw for HTML pages. Is to get the authentication for this Python script to read and write information from the Google Sheets. So yeah, so for this we are using .NET API of Google Sheets, and if you follow this link shown on the screen, we'll get all the libraries necessary and also the guides and references to achieve this. So it's basically a very simple code snippet where we get the authentication to read and write information into the Google Sheets for our program. And having got the authentication, we will read the information from the Google Sheets using this Python node. So we are basically getting all the information from the Google Sheets using the authentication received earlier in the previous node, and then the spreadsheet ID, the ID of the Google Sheets which we are populating the data with, and the sheet range. Sheet range is always going to be the full sheet because we are going to populate data into the entire sheet. So with that information, we are going to read all that information. We are going to read all the data in the Google Sheets and then pass it out as a list. So after this, we have this reference list, which is kind of a global variable where the master data of Google Sheets will be stored. And then we are going to use the third Python script node, which I'm going to explain now, to compare the data with the master reference list and then identify the information that has been changed or altered recently. So after getting that information which is changed, comparing with the global data, we will pass it on to the last Python node, which will update the status into Archicad. So for this, we are using JSON script by JSON API developed by Graphisoft. A similar approach was earlier done using this JSON script by Enzyme team. We are also following the same one now, and we are basically reading the information. We are using JSON script to communicate with the Archicad model that is open on the same machine. So using this, we are able to communicate with the Archicad model in real time and update the statuses. So having all the statuses updated, we can now visualize the information on BIMx, which is again using an API functionality. As I told earlier, we are using web services to generate the URL from the Google Sheets and pass it on to open the BIMx model. So which shows the BIMx model in real time, which means that anybody from anywhere can use any device to see the statuses, including the developer or the owner, whoever it is, with respect to project stakeholders. And after visualizing, I think we are done with the system architecture. So we will go ahead to see the pros and cons of this NFC based tracking system. Basically, there are more pros than cons. It's very budget friendly because we are going to use just the mobile phone and NFC tags. These tags are very cheap that you can buy multiple tags for cents when you go for bulk purchases. And these tags are very convenient to use, meaning they are like weatherproof, and they are very versatile, meaning you can store URL data, you can store any kind of information. But when compared to RFID, it's kind of you can store only hexadecimal numbers. But since NFC can store any data, we can use it for multiple purposes, and it's battery friendly also. When it is compared to RFID, again, RFID basically works with the mobile device using the Bluetooth, but here NFC is triggered only when you click the button or when you trigger it. And again, having the payment options available on recent mobile phones, which is very secure, NFC is also like very secure solution for now. And the other problem with this solution is low range, and it is also believed that this technology has been designed in such a way that this low range is itself a security for using it. Yeah. And after this, we can go for cost comparison with different solutions. We have this NFC, which is a low budget one, as I told you earlier. And with RFID, we can do some more automations with a medium budget. But for a full automation, we need to combine multiple IoT sensor devices to go for full automation. A research project which aimed at doing full automation was earlier done by NTU under Prof. Robert Tiong, funded by JTC. If any information is required about the research, you can always contact Prof. Robert Tiong. Yeah, so with this, my presentation is over. Sorry for going into so detailed. I had no choice. Thank you. If you have any questions, you can ask.
Great stuff, Vimal. I think I've been checking here on the chat, and I'm glad it's very live. A lot of people are giving feedback. Pretty much, I think that the audience is kind of in awe in terms of what our team has put together and has developed. I think the main takeaway we can take from today's session is that we can have very practical approach to the technologies that are out there and combine them with BIM, and even use something like Google Spreadsheets, which is something that we might use on a daily basis for other stuff, and take advantage of the connection and with between all these different technologies, some hardware, some software. So it's a matter of putting the creativity to use to solve a problem, right? And I think the team did a good job in showing how we can overcome to deliver very practical issue. This is, I think, in my opinion, the true open BIM, which is we're using BIM in the center of everything, like the center of information. So it's pretty much the model that goes through every single project stage, and we are performing, a series of milestones that we need to achieve by connecting with other tools. So that's why we don't believe in silos. That's why we don't believe in only one tool to solve everything. And we believe that these workflows and sharing workflows between the industry, and it's the way to go. Thank you.